Now please let's look up. Now we are going to be looking at high energy compounds and high energy bonds. High energy compounds and high energy bonds. Now when we talk about high energy compounds are also called what? Energy rich compounds. So it is either you call it high energy compound or you call it what? Energy rich compounds. And high energy compounds are compounds containing high energy bonds that on hydrolysis release energy of greater than or equal to 7.3 kilocalories per mole. Any compound that when you break that compound down, the energy release is equal to or greater than 7.3 kilocalories per mole, we call that compound what? High energy compound. But if on hydrolysis, the compound releases energy that is lower than 7.3 kilocalories per mole, you call it what? Low energy compound. Do you understand that? So high energy compounds contains high energy bonds, energy rich bonds, that when you break them down, they will give energy of greater than or equal to 7.3 kilocalories per mole. Now, when we say give energy, with the value of the energy given be negative or positive. Positive or negative. For us to say release energy of greater than or equal to, will it be negative or positive? If delta G naught, if delta G is negative, is it releasing energy or giving or taking energy? Releasing energy, right? So it will be what? Negative. So delta G naught value, looking at high energy compounds, their value is always negative. But here we are saying greater than or equal to, because I didn't put minus here because I've said release energy of greater than or equal to this. So using that word release energy, you should know that this value should be what? Negative, right? Because energy is given off. If we say absorb energy, positive, release energy, negative. Good. Now, high energy bonds are found in high energy compounds, and high energy bonds can be grouped into can be grouped into 5. The first one here is phosphoanhydride bonds. Now let's do a little bit of chemistry, simple chemistry. Now if you have something like this, what functional group is this? Alcohol, right? If you have something like this, what functional group is this? Ether, right? Good. On Asabi Buko. If you have something like this, what functional group is this? Carboxylic acid. If you have something like this, what functional group is this? Ester. If you have something like this, what functional group is this? Acid anhydride. Good. If you look at this acid anhydride, you notice that it's actually 2 carboxylic acid they put together, right? And remove water. Anhydride means remove water without water. Acid anhydride, you're joining 2 carboxylic acid and you're removing water. Now, phosphoanhydride. If acid anhydride, 2 carboxylic acid, removing water. Phosphoanhydride will be what? Joining 2 phosphoric acid, right? And you're removing water, right? Now, phosphoric acid is H3PO4. If you are drawing the structure, it looks like this. This phosphoric acid. If you have another phosphoric acid here, and 2 of them combine together, condense to release water. Water is H2O, right? So HOH, water. So this part is going off. Then we now have this. This bond formed between 2 phosphoric acid molecules is called what? Phosphoanhydride bond. And it is the lowest in energy. Example is found in ATP. What is the full meaning of ATP? Adenosine triphosphate. Adenosine triphosphate contains 3 of these phosphate. This one is diphosphate. If you add another phosphate group, triphosphate. So phosphoanhydride bond is on here. They are the lowest in energy as they release energy of approximately 7.3 kilocalories per mole of energy. That's phosphoanhydride bond. The second one is enol phosphate bond. Everybody in this class, you know enol phosphate bond. Now look at this. If I have something like, can I clean this one? If I have something like this, is this an alkane or an alkene? Alkane or an alkene? Alkane, right? No double bond, is it not? If I have something like this, is this an alkane or an alkene? An alkene, right? Because there's a double bond. Now here we say enol. In all. All is what? Alcohol, right? In double bond, right? So if we have enol, it means the OH is placed on a carbon bearing what? Double bond. Is it not? So enol, we are talking about alcohol placed on a carbon bearing double bond. That's enol because in double bond. For example, this 18, right? In. All is for alcohol. So if we want to draw the enol phosphate bond, is formed between phosphoric acid associate group and an hydroxy group of a carbon bearing double bond. Without much story, see what I mean? This is my phosphate group, right? Now, if I have something like acid, this is it. This is the structure of phosphoric acid. Now, if we have an enol, is this an enol? Is this an enol? And it is an enol because this OH is bonded to a carbon having a double bond. Is it not? This arrow represents the alkyl chain. Now, the bond is actually formed between the phosphate group and the hydroxy group of carbon bearing double bond. I wanted someone to point that out. So it is formed between phosphate group and hydroxy group of a carbon bearing double bond. So H and OH is going out, and we have this. This bond formed here is called the enol phosphate bond. So it is actually the phosphate group that is involved. The OH on the enol and the phosphate group that forms that. That's the enol phosphate group. And it's found in a compound called phosphoenol pyruvate. It is the richest in energy, as it gives energy of about approximately, I think, 14.3 kilocalories per mole. It's the richest in energy. The richest. Phosphoenol pyruvate is very rich in energy. The third one, very quickly, acyl phosphate bond. Acyl phosphate bond is formed between phosphate group and what? Hydroxy group of a carboxylic acid. So between phosphate group and hydroxy group of a carboxylic acid. So if I have my carboxylic acid, this is the general formula of carboxylic acid, right? And I have my phosphate group, phosphoric acid. And there's a condensation. Water is always going out. If you notice all these ones, water is always going out. So H takes OH, water goes out. And we have this. This bond formed here is called what? Acyl phosphate bond. So acyl phosphate. Anytime you hear acyl, acyl is related to carboxylic acid. Now, acyl phosphate bond is formed between carboxylic acid and phosphate group. Please, in exam, if you are asked to explain all this and you draw all these things for them, you are accumulating marks for yourself. Alright, so that's that for acyl phosphate bond. Can we continue? Can we draw that? Now, if we want to look at the third one, the fourth one, guanidine phosphate bond. Guanidine phosphate bond, we said is formed between phosphate and a guanidine molecule, right? And what we said, what's a guanidine molecule? Guanidine molecule is what? Carbon that has 3 amino groups bonded to it, right? Carbon with 3 amino groups bonded. So if we have a phosphate group here, and we have a guanidine molecule, let's take it as this. Let's take it to be this. This carbon is triply bonded, like it is having 3 amino group. If this H takes this OH out, what we are having is a guanidine molecule, is a guanidine phosphate bond. It's a guanidine phosphate bond. Sometimes the amino group we have can be a secondary amine, but I don't want to go into that. Then the next one, thioester bond. Thioester bond is not, okay, this guanidine phosphate bond is found in phosphocreatine. Phosphocreatine is found in the mosaics. It's energy source in the mosaic. Now, thioester bond is not a typical high energy bond because it does not contain phosphate, high energy phosphate bond. So if you asked to give an example of high energy bond that does not contain phosphate, thioester bond. Now thioester bond is one between two things, what and what? Thioester bond is one between what and what? Carboxylic acid and what? And sulfur from SH group. Now, if I have carboxylic acid this way, plus SH group, if these two things combine, what I will always be giving of OH will take H here. So if OH takes H, what will be left with is this. This is the thioester bond. Thioester bond. And it's found in compounds like acetyl-CoA. If you draw the structure of acetyl-CoA, you have something like this. This is the structure of acetyl-CoA, and you can see this thioester bond in it. So thioester bond is formed between carboxylic acid and SH group. So basically, these are the high energy bonds we have.